All right. Hi, everybody. So good. I guess it's good. It's good evening or something. Um, yeah, I wanted to start off by asking if we could have somebody help us confirm that you can see my screen or something. And if you can hear me, you know, so that we can you hear me just fine? Like, can you see my screen?
Yes.
Yes, we can hear you.
Yeah, thank you so much, colleagues. Thank you so much. I do apologize that we started a little bit late here. I'd said 45, but stop somewhere around 21 here. That's fine as well. I don't mind. I normally have a class between 17 and 17:45, and you know, the problem with that now is that the problem with that class is that sometimes there are questions that have got to be addressed and whatnot, and so which is why I was slightly delayed. I do apologize for that, but nonetheless, we're going to continue. Something else I wanted to mention here, everybody, is that you see, over the weekend we had planned to have a makeup, but I was not feeling too well. I don't know. I feel like I'm coming down. I was feeling like I'm with a flu here, so I just figured I needed to rest a little here. So having class here. So in any case, I mean, we can have our makeup this coming weekend. I'm all geared, nothing planned, but also we have a series of holidays coming up here. So my thinking is we can take advantage of those holidays as well to have more makeup classes here. And there's a reason why we are doing this, by the way, right? We have quite a number of colleagues that are doing this for the first time, so they don't necessarily have that much experience when it comes to programming, if you will. So we take baby steps here, so we need a little bit of time. Now, when I was planning for, I don't know, I guess today or something, I don't know, I sat there and I was thinking to myself, to what extent should we actually maintain the things that we said we'll do, right? The things in part number, is it part number 2, number 3 or something? If you remember, we still had quite a number of things we needed to discuss because we started late actually in that lecture, that inaugural lecture, the Administrivia lecture. But also at the time, for the most part, we basically just spent our time, in essence, just, I don't know why this is taking a while here. We spent our time admin-centric things associated with the course. There's still a couple of other things that we said we would do, but I'm going to cruise through them because I would much rather today we actually start lecture series number 2, right? And my plan or our plan is going to be such that when we, as we're covering certain topics, we'll actually revisit some of the things that I really wanted for us to discuss, if that makes sense. Okay. Anyways, so we're going to continue here, right? And if you remember, when we met last time, we went as far as oof, I don't know why this is taking a while here. We went as far as so we discussed the course and all that, Administrivia. We discussed prescribed and recommended textbooks, tools that we're going to be using, and incidentally today we're supposed to start looking at some of these tools, right? Because this is a programming intensive course. It's important that early on in the process we introduce you to these tools that we're going to be using so that you're not lost in the source. So we did this, and then we discussed course grading and all that, and I directed you to some very important document, which is the postgraduate guidelines. Hopefully all of us have had a chance to read through the guidelines and all that, which is a good thing, I guess. I don't know. And then today, right, in terms of the course introduction, in essence, I had it in my mind that I was going to walk us through some ongoing projects where I was going to focus on the data, right, that we're analyzing, right? And the thinking there was to focus on the data science aspects of this thing, try and link it to the things we're going to be doing in here. But I think I'll just bring up these things. My plan is I'll bring up these things in more detail when we're covering specific topics in the course. So I'm just going to mildly talk about this. So there's this project, right? We initiated a while back here, and it's in a subfield of AI called natural language processing, right? What we're doing in this particular course, right? The problem we're solving is simple. If you look at the data that is produced, right, by I'm going to close this. If you look at the data associated with institutional repositories at the UNZA, remember I think I mentioned that UNZA has an institutional repository. I don't know if I mentioned this, but I want to mention it. But UNZA has a number of systems, right? One of those systems is quote-unquote institutional repository. And on this institutional repository, you have the university showcase research output. Now, crucial to research output for any university is what people like you do. Okay, so the research that you conduct in partial fulfillment or in fulfillment of whatever program you're pursuing. All right, so in the case of the University of Zambia, we have isolated the things that are produced, the manuscripts that are produced by doctoral students and master's students. So there's a community called thesis and dissertations. And if you go in here, you will find the work, right, that has been done by students that have graduated, successfully graduated from the University of Zambia. If you look at the number here, like currently, we have a total of about 5,725, supposed to be slightly more here. This number will kind of hint at interesting figures, statistics, like how many people have graduated from the UNZA, for instance, right? In fact, you can even take a look at the things that have recently been done here. You can organize these things in descending order or something. And then we see that we'll start seeing things that were done as recently as last year, right? As recently as last year. Now, the problem we're solving here is, it would seem like trivial here, but it's more focused, like not trivial, it was difficult, but it was simple, right? If you look at a dissertation like this, I don't know what this was here, but this is a dissertation that was done by Nkonde Frida. We can open the actual manuscript here to have a sense of what this manuscript is all about here. I'll come to the document and download it, and we can also view the full item, right? So we see that this is either a PhD manuscript, a PhD thesis manuscript, or master's dissertation / manuscript produced by this individual called Frida Nkonde Frida. And we see that apparently it's a thesis, right? Master's degree of communication for development or something. I don't know what this is here. I don't know. Communication for development. Now, what we discovered is the way the UNZA does things here is that it's difficult for us to know who supervised Frida Nkonde, because at the University of Zambia, like many universities, master's students or postgraduate students who work under the supervision of so-called supervisors or advisors, depending on where you're coming from. So lecturers, right, that have experience in that particular research area. Now, so the supervisor details are an integral part of description of this information. In fact, if you look at places or universities like my alma mater, is it open? Yeah. My alma mater, you notice that they actually provide this detail. So if I open up metadata associated with my PhD thesis manuscript, I just go to full item page here. You notice that on this page, somebody can intuitively know who advised Lighton, right? So Professor Suleiman and Professor Dr. Christoph Maino are my advisors, right? This is not there for the UNZA. Now, because it's not there and we have a lot of documents, the question that we're trying to solve in this problem is, how can we, because one of the viable solutions here is you have people open up these 5,725 documents one at a time. You open up a document like this, right? The actual bits from the PDF document like this, and then you start checking. Who was the supervisor here? In this particular case, is Dr. Brenda Bukowa or something was the supervisor for this person. And you say, well, we get that information and we alter the metadata so that we fix it and we include a dc.contributor.advisor, Bukowa, Brenda or something like that. But it's not sustainable, right? Because you're looking at a lot of documents. So what we did was we decided to build an automated way of figuring out this information. Now, what we discovered, right? By the way, this is wrong. If you look at the guidelines, you're not supposed to have supervisor details on the first page. So this is horribly wrong here, poorly formatted. But what we discovered was that for most documents, these manuscripts, in fact, I can come here and look at other manuscripts, like let's look at this other manuscript by Enoch Chilambula or something. And this is from, I don't know where this is from here. We're just going to check it. I don't know which school this is from here, but we'll probably check it and see where it's from. Hopefully we'll be able to manage. But what you begin to notice is that this information is actually found somewhere hidden in these documents. The actual PDFs that these people wrote using Microsoft Word or LaTeX or something. It turns out that there's a section of the document where you find this information, right? Let's look at this other example. You notice in this particular one, there's nothing on the first page, right? Like the supervisor. We don't know who the supervisor is. So what do? We discovered that when you scroll down here and you go to this section called the acknowledgement section, you typically have statements where students will almost always, and in Zambia, almost everybody, master student, PhD student, will thank God, most of them, and then their supervisor. So we're looking for statements like, I would like to express my deepest gratitude to Professor Jason Mwanza for his invaluable, guidance, blah, 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 and stuff. So this was the supervisor. We go to another one, we can check, and you discover that there's a pattern here. Typically in the acknowledgement here. Oh, there's God here. First and foremost, I'd like to thank God and stuff. Somewhere here is my deepest gratitude goes to my supervisor, Dr. Brenda Bukowa or something like that. And so what we discovered in this thing is we could fix this problem by collecting this data or analyzing this data, which is found in the PDF document, but in a specific section of the PDF document. Now, if you read up, right, on the report, the technical report that was produced as part of this project, we provide details on how we are doing this, right? It's a heuristic, actually, where we get the entire PDF document and then we check on what page is the acknowledgement section. When we find the page where you have the acknowledgement section, like in this particular case, so this page 1 of 79, I'll start going. Page 2, page 3, page 4 here, page 5, abstract, page 6, dedication. Page 7 is where you have the acknowledgement section. So what we did was we are mining this information, right? Extracting this page. Yeah, and really extracting this page is not that difficult. Would come, I can showcase how, I guess, how you could kind of do this here, right? You could say, I'm going to get this main thing here, main document, and then I'll just say sample etd page acknowledgement.pdf, right? So what we're doing is we're using PDFTK here. You'd say PDFTK, and then you'd have something like cut. I'm going to get page number. I'll get page number 7, right? 7 of 7. Let's get 7 of 7 here, and then the output is here. So I get that page. So what I'm doing here is I'm cutting out that page, right? We cut it out, and then we have something like this, right? So for each of those 5,000 things, right, you extract these things here where you have the acknowledgement, one page. When you get this page, again, using a computer program, you'd say what I'm going to do is I'm going to do a PDF to text or something. I want to do a PDF to text to this page that I've extracted that has an acknowledgement section, right? And then what you begin to notice is when you have a TXT file here like this, it becomes a lot easier for you to programmatically read what is in the file, right? So this was what we were ultimately programmatically analyzing ideally. But there's more stuff we're doing, right? In here, we're using kind of like named entity recognition, right? Which is part of natural language processing to find names of things and specifically names of people, right? So ultimately, the program that we were working with would output something like this. You notice here, entities are color-coded, right? Purple and that's green or blue or something. That's blue. I don't know what that is here. But what we're interested in are these things in purple, right? These are names of people: person, 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 organization, organization, person, organization, organization, right? And then we extract that information. So in essence, the whole thing here, the pipeline I was explaining from you, downloading the file and cutting out the PDF and converting the PDF to text and then loading that text into Python pandas and then analyzing the data was all done using computer programs, right? And in fact, our pipelines, when I'm working with students like this, our entire pipeline is made up of, it's created using Python, not PHP, fundamentally. So that's such project, right? An interesting project. I'm going to talk more about this later on. At some point, found ourselves trying to automatically detect which collection a particular thing should be input into. Again, it's tied to this. We do a lot of problems associated with the repository at UNZA, right? Part of what these people from the library do, is they go through this really time-consuming workflow, right? As they're depositing these things in the repository. And because it's time-consuming, there's a huge backlog. So it's like, how do we address this problem? Well, we can mimic what a user does when they're going through that workflow and automatically determine where exactly that thing should be deposited, right? So automatically tag it with a community and collection it should be associated with. And so in essence, you're just building classifiers, is it? Yeah. A simple program here. Again, we were harvesting data from the repository, but different sort of data. In this particular case, we're getting metadata, not the actual PDF, but we were interested in this metadata here. Right? So if you go to the repository itself, the repository is accessible here. And so what we did is we were using the so-called application programming interface, the Open Archives protocol for metadata harvesting, OIPMH protocol. And so we're doing this. When we go to the browser and we get the metadata, but we get the metadata using a specific verb, right? List record verb. Now, if you get the list record verb, this, you notice that the URL is slightly different, right? It's this long thing here. And it turns out that using this long thing here, you can extract really rich set of data, right? So I use curl here and I get this. You'll notice that I'll be able to get an XML encoded representation of the descriptive information, this stuff here. This is properly encoded, right? Well structured. If you notice each record, you may not see this here, but each record is wrapped into specific tags here. So this is the data we're working with. Again, getting access to this data, this XML encoded data, was done using a Python stack ideally. For the longest of time, I've been affiliated, not anymore now, I don't actively participate in the university ranking committee. So we compile data. The university has a ranking committee that compiles data, which is then used to help rank UNZA. So if you've ever seen UNZA ranks number, I don't know if it's number 6 or 16 or something, you need data, right, for it to be ranked. It's a manual process, but it turns out that part of what we do was, I used to do anyway when I was closely tied to the University of Zambia ranking committees, would actually automatically pull information from Google Scholar, right? So write scripts and pull that information from Google Scholar. Anyways, there's another project where I think I gave an example of this project where I said, there's a first year course that I taught for many, many years, right? Between 2018 and I think 2023, 2024, somewhere there. And the failure rate is quite high in the course. And so the question was, how exactly would we go about solving this problem? Right, so we built classifiers that are able to tell us which students are more likely to fail using specific markers. And it turns out that for us to build those classifiers, well, we had to harvest that information from the University of Zambia Learning Management System, Moodle, right? So if you go to Moodle, for instance, you log into Moodle, well, you have, depending on whether you have the permissions, you have access to usage logs for each course. So one of the courses I teach is this year is an undergraduate computer graphics course, for instance. And if I go to the settings and I check, it's quite a bit happening here. We've gone as far as lecture series number 4 or something. If I go to check the logs here, you begin to notice that there's actually a rich data set here, right? Quite busy course here. And also a number of students are enrolled in here. You know, you notice here that there's a student here. This is me because I was auditing the course literally. I don't know how I found myself doing this a few minutes. How? What was I doing at 1803? I don't know. And then there's this student, right, who downloaded lecture notes here. This same student downloaded our requirements.txt file because we got into a stage where we're discussing the programming language that we're going to be using and the specific libraries we're going to be using, right? And then you have this student here downloaded the requirements file and stuff. Anyway, so the idea is we were using Python to actually harvest this information. And so what you're seeing here, right, in this image, the black portion of the image here, is a visual representation of like reduction. Okay, I've worked with students that have been interested in trying to understand whether certain pieces of technologies are useful, and at some point we'd explored the possibility of harvesting usage logs from these small tablets that kids use, right, from grade 1 to 7 or something, to try and understand exactly how they interact with these sort of technologies. You know, so there are a series of examples, really. I'm going to sneak these things in as we go along, but I wanted to give you an idea. Some of them are quite obscure, like the Enterprise Medical Imaging in Zambia project. The type of data we're working with, or data we're manipulating, really, is from medical images, right? So the actual image itself, the pixel representation of the image, because when you're analyzing an image like this, what you do is you work with the ones and the zeros, right? Or rather, the pixel representation, the pixels that actually make up this image. So the RGB and maybe alpha values that make up an image like this, and you analyze those things. In addition, what you do is you'd be analyzing what I introduced as the descriptive information about the DICOM file, is it? We discovered that, or rather I hinted last week at the fact that your DICOM file is like an image, right? So a DICOM file has metadata embedded just like your image has metadata embedded. I gave an example of this, if you remember. I gave an example of this to say an image like this, right? An image like this, whereas you're interested in the content like this image here. But it turns out that embedded within this image is descriptive information, in other words, metadata, rich metadata. So what we're doing with the DICOM file is we're analyzing this sort of descriptive information. Now, the metadata elements associated with DICOM files are quite complex, right? 5,000 plus elements of those things. Anyways, so I'm going to talk more about this later on as we go on. I wanted to kind of like waste time or spend time talking about the Enterprise Medical Imaging in Zambia project and really talk about the data that we've been analyzing for the various packages, but it's a bit too much. I'm going to skip these things because I would want us to just have a sense of where we are going. I think that's even more important, right? a sense of where we're going. But we've done a lot of amazing things as part of this project. We're trying to contribute in our own small little way here. And then towards the end, I also give kind of like examples of potential sources of data, like social media, for instance. These things that we see around, especially cameras that are dotted all across the city or all across the country, right? You go to high density areas like Kamala South, for instance, and you'll find these things here, right? Question to ask is, who is mining this data, and how are they analyzing this sort of information? Anyways, but it turns out that central to data science is data, is it? So we're trying to understand exactly how we're going to be, mining this data, extracting this data, preparing it, and then ultimately analyzing it to derive insights, ideally. Okay. And for us to do this, it turns out we're going to have to work through these key objectives, right? These are the key learning outcomes associated with the course itself, 6741. So we're supposed to get to a stage where we're able to write Python programs that will enable us to solve data science problems. Okay, we should get to a stage, that is, by the time we get to April, we get to a stage where we are able to use essential Python libraries that are used for data manipulation, analysis, and visualization. We should be able to perform data wrangling, cleaning, and processing efficiently. So prior to analysis, we've got to clean up the data. And then we should get to a stage where we're able to implement very basic, machine learning algorithms using Python, right, for derivation of insights, right, for us to extract knowledge from the data, ideally. And then also, we should be able to get to a stage where we're able to create clear and informative data visualizations. And of course, we're supposed to get to a stage where we're able to work with real-world data sets, right, and prepare them for analysis. So if somebody comes to you and say, we have this large Facebook page where Ministry of Health or something, or maybe Ministry of Tourism, and because the elections are coming through, we just want to get a sense of, how much we've done here, right? So we're looking for somebody to mine data from our Facebook page and analyze it for us. By the time we get to April, you should be able to do those sort of things, right? Real-world data sets, prepare them and then analyze them, prepare them for analysis and then analyze them using nice visualizations here. Now, it turns out that for us to do this, we're going to take an approach where we look at these different learning outcomes from the perspective of thematic areas. I've called these thematic areas. I guess we can also call them modules or something. So maybe I will change the next lecture series to be module 1, right? Because we're talking about a lot of things in there, not just one topic. Okay, so theme 1 or module 1 is going to be an introduction to the Python programming language. And specifically, we're going to be looking at the Python programming language from the perspective of data science. You will notice in our introduction to Python that Python is considered or is classified as a general purpose language, meaning that you can use it to write or to create software applications that can be used to solve or address data science-centric problems, software that can be used to create graphical user interface applications. Like I used Tkinter for a very long time when I was a graduate student. I used to be a teaching assistant for this first-year course. You can also use Python to create web applications, right? So our interest in Python is going to be how exactly do we use this programming language for data science. And in order for us to do this, we shall start off by looking at Python. We'll look at an overview of the Python programming language, what it is, what's the fuss about it. We are cognizant of the fact that there are some of us that may have zero experience with Python. I guess I'll do a poll here just to be certain. But we'll see how we can set up a Python environment so that we're able to write computer programs, right? And then we'll jump into the programming itself. So we'll look at the basic Python syntax, right? The anatomy of your typical Pythonic program or something. How do you create it, right? What are the various components? And then once we do this general introduction, we will then look at the quote-unquote native Pythonic data structures, right? And specifically, I want to focus on lists, tuples, or tuples, depending on where you're coming from, dictionaries, and sets. What you begin to notice is that these sort of data structures are used for different sort of things, right? So you will see me at some point giving examples like, oh, I don't know where this is, but maybe I can go to my my environment or something. It's much easier here, I guess, because I've created this environment specifically for this course here. So you'll notice that I'll be doing things like, well, if you are using Python like this and you create something like list, right? Well, this is how you create your list, for instance, right? If you check the type, is a list, right? It's a list, so type list. And again, you notice that this native, Python data structure is so interesting because when you have this sort of data structure, you can do things like you can extract, you can extract things that are in here. Like I want the very first item, for instance, right? Or I want the last item in the list or something like that, right? You can do things like you can count the number of things in a list, right? And they have so many different characteristics. Compare and contrast with what we introduced as a tuple, right? And you discover that, oh, we create it like this, right? 2, 3, right? If we check the type, it's going to be a tuple or something, right? Or tuple, depending on where you're coming from. And oh, it turns out that the tuple can also, it's iterable, so we can check what is on element number 1 or something. What is at the end, right? It's iterable also. But what you discover is that these data structures are used in so many different scenarios, right? Like for instance, a tuple is immutable. You cannot change it, right? With a list like this, you notice that, oh, a list, if I look at my list here, I can say I want, can I do this? I want this to be equal to -1. Right? And if I check my list, I now have -1 here instead of the 1 here. But if I get my tuple, for instance, a tuple, depending on where we're coming from, I can't do this, is it? I can't say this, can I? I don't think so. I want this to be -1, right? It's immutable, right? So we discuss these structures, data structures, and it turns out that when we're discussing these data structures, we're discussing them way before we start looking at other complex data structures, right? Like data structures that you find in NumPy, for instance, numeric Python. Right? So we'll do this. So our focus really when we look at these 4 Pythonic data structures is going to be to understand how we work with these data structures, in what sort of scenarios we may want to use them, right? And then at some point, we'll try and have a discussion of list comprehension, right? And lambda functions, ideally, fancy ways of working with these sort of data structures. Because in a real-world setting, right, you wouldn't be working with a list with how many elements? With 3 elements. You'd be working with a list comprising of, but where are you now? Right there. Comprising of these, so you load all of these things here, these dissertations, 5,725 into a list. So a list is going to comprise of 5,725. And it's like, how do you go about manipulating, your items, the items in that list, in that tuple or something like that. I guess, I don't know. Okay, so that's module number 2. And then in module number 3, we're going to now start looking, beginning module number 3, actually, theme number 3, we start looking at libraries, and I'll explain what libraries are in the next lecture series here today, actually. But the idea behind the library is simple, right? It enables you to extend the basic or the native functionality of a programming language. Remember, I mentioned Python is general purpose, so it can be used for scientific computing. Literally, in my 4th year, yeah, there we go. In my 4th year programming course, if you notice, it's CSC 4505. We are using this, right, to understand computer graphics. So we're using this to draw primitives, right, I guess in model space or something. So like triangles and how you create a mesh and all those things. Completely nothing to do with what we're doing in this particular course. But the way that I transform Python to enable me to work with computer graphics is I'm installing specific libraries. In this particular case, we are using the key libraries we're using. Well, I mean, it's NumPy, obviously, for creating our vertices or vertex, right? And their corresponding properties. But also, we're using Pygame, right, for windowing, and then PyOpenGL for drawing the actual primitives. But for the course that we're doing here, we are interested in packages like Matplotlib for graphing, NumPy as well, right? Pandas, yeah. Things like where are you now? I don't know. Seaborn, right? You know, so the way that I do this is I use what are called libraries, right? And so the way you extend Python is you download those libraries, right? Like in this particular case, if I didn't have it installed, I'd say, I want to install Matplotlib because we're supposed to study Matplotlib for visualizations, or the pip install Matplotlib or something, Matplotlib. And then this thing is going to download the package, right? And kind of like associate it with my Python programming language. And what this is done, as I'm using Python here, I can import, right? I can import something like pandas, right? As PD. And then in here, I'll be able to read data from different sources, right? Read from Excel. I can read data from an Excel file, from a CSV file, you know, from HTML page, you know, from a JSON encoded file, from SQL, using an SQL query, all sorts of weird things here, from XML encoded data and stuff. Okay, so we're going to start off by understanding the NumPy library, right? So you will see me, once we get to that stage, we shall learn how to do things like import NumPy as NP. When you import this, you can then have an understanding of what sort of things are in this NumPy library. What sort of things do you gain access to, like that? What else? Well, you can check the help, right? The manual associated with the NumPy library itself. And this thing will tell you that NumPy is actually, let's say, provides an array object of arbitrary homogeneous items, fast mathematical operations over arrays and stuff, linear algebra, you know, Fourier transform, random number generation. I'm guessing the math majors in the room here, our math expert will remember your Fourier transforms, right? Anyways, so we're going to look at NumPy. So we'll see how we go about creating NumPy arrays, matrices, and just basic operations in NumPy, right? So how we index things in a NumPy data structure, right? So you see me doing things like np dot array or something, array, right? I created a NumPy array values. I think I can. Oh, I didn't create a list there. I want to create a NumPy array, right? Which comprises of this 1, 2, 3. I don't know why this is. Know why this is fading here. Have to be an easier way of creating a NumPy array, I guess. Anyway, when the time comes, we'll look at this. So creating a NumPy array. And then also when you create your NumPy array, the idea is, because this array will probably be made up of a lot of elements, is it? A lot of items. So the question will be, how exactly do you get to access the things in there, right? So how do you slice the NumPy array to extract elements from there? In addition, we will also look at this notion of broadcasting in NumPy. And then there are apparently some mathematical functions and operations that we're supposed to introduce you to insofar as NumPy is concerned, right? So we'll look at all of these things. And the beauty is, it turns out that what is key to these so-called libraries really is you just need to know exactly how to use the library. And there's almost always a manual, right? There's almost always a manual. So in here, for instance, if I do help np, right? if I do help NP, somewhere in here, there's an outline of how exactly you get to use a number of these functions that are associated with classes, functions that are associated with NumPy IDEs, right? So you have access to your library. You don't have to memorize most of these things. Items. I'm surprised that this thing is. I hope my installation of NumPy is okay, right? Don't know. 2, 3. Okay. So it looks like it didn't. It wanted me to assign a variable to this, but why? Why did it fail before? I don't know. So you will see us doing some of these things, right? Items, right? NumPy array, and you can do fancy things here like kind of check dimensions associated with this, right? ND or something, right? So 1D here. Whereas if I decided to create something like this, let's say 2D or something. Let's say in here I have a list within a list, and then I have 1, 2, 3, and then I have 4, 5, 6 or something like that. And then if I check the dimension to the ending here, it shows me this is a 2-dimensional structure here. Anyway, so we're going to look at NumPy, right? We'll have fun, I guess. I don't know if you're programming for the first time. I think you'll have fun as well. It's always fun, right? To actually tell this machine, we call a computer, what you want it to do. That's the fun part of programming. And then after our discussion of NumPy, we're supposed to extensively look at Python pandas. Now, Python pandas is you can actually view Python pandas as being Excel on steroids or something like that, right? It enables you to analyze data like that. In comparison to Excel, you're able to work with relatively large data sets, millions of records ideally, right? So we introduce Python pandas, like how you go about installing it so that you can use it like this. And then again, just like Python, I guess NumPy, for instance, you can gain access to the manual, right? Where the documentation is telling us pandas is a powerful data analysis and manipulation library for Python, right? Very powerful, actually, extremely powerful. Right? So we'll look at how exactly we'll take advantage of Python pandas way to analyze data, right? So we'll look at things like how we load and exploit data sets, right? From CSV and all that. It's gonna be fun. How we do data selection, how we filter records, because when you have the large data set, like from here, 5,725, it's like we only wanted to see things from the School of Natural Sciences. So we filter by the school. So how do we filter? Programmatically, ideally. How do we sort? How do we handle missing values or missing data? Okay, because when you're working with data, it's usually not clean, is it? You have to clean it up. If you look at this data, for instance, before you start analyzing it, you clean it up, you process. And part of the preprocessing task that you perform is deduplication or handling null values, right? So we're going to look at how exactly we handle null values and how we duplicate using Python pandas. Quite fun, really. And then we'll look at things like groupings. These are when you're working with a pandas data frame, you can do things like fancy things that you do in Excel, like pivot data. You can group records or something. Look at all of these things, reshape data and stuff, right? Reorganize it so that the rows become your columns and the columns become your rows or something like that. And then look at time series data manipulation with pandas as well. So you notice here, right? Beginning module number 3, we're actually studying specific data science-centric libraries for the Python programming language. NumPy, pandas, right? NumPy for working with multi-dimensional data structures, right? Or for working with data structures that are more efficient. Instead of using your native list, for instance, you're better off using a NumPy array because it's much more efficient, it's faster. And really, when you're working with computers, efficiency is king. Although these days, you see now, these days, it's no longer such an issue because it's not like when I was a student where computer which is in the lab has 32 GB is something. Well, now we work with computers that have 40 GB of RAM, right? Like, so, but what the hell are we even discussing? Why the hell are we even discussing efficiency? I don't know. So NumPy and then pandas, right? A separate library. So we'll look at how we install it, how we use it. Okay, what exactly do we use it for when we're talking about data science? And then we go to, again, two separate libraries. We'll first of all start with our discussion of one of the most widely used visualization packages or libraries called Matplot, right? Again, if I come here and I say, if I install Matplot, I'll just say import Matplot lib, right? And import Matplot lib, like that. When I import this again, I can check the manual, right? Help Matplot lib. And this thing tells me that Matplot is an object-oriented plotting library. So it's easy to draw graphs, ideally, right? So you do things like import, is it Matplot lib.pyplot as PLT, and then you have something like PLT, I don't know, PLT dot py or something, and then pi or something. But how? 20%, I guess 20%, I don't know, 50% are female, 50% are male, something this way. And I'll do something like PLT dot show, something like that. And then I don't know if it's there. I don't know if it's there. The graph. I wanted to showcase the graph on the graph PLT. I don't know why it's not showing. I don't know why it would be saying canvas not showing here, right? I don't know. The standard output. You look it up. The thing is, I've just set up my thing here. Probably we need to configure it in a certain way. I don't know why I'm getting that, but I just wanted to showcase the graph itself, the visualization. But you know what? I could just as well have easily done this in Google Colab. It's one of the reasons why you'd probably want to use something like Google Colab or something, is it? I don't know. Maybe not. I'm wondering what is happening here. My connection is a bit. I hope people can still hear me here.
Yes, we can hear you.
Connection it's lagging, I think.
Can hear you.
What I'm going to do is I'm going to switch connections here. I don't know what's happening here. Yeah, so what I'm trying to do here is fading there, but so I can use Jupyter, I guess, notebook to kind of showcase this. Is a thing. I guess I'd have to configure my environment in a certain way here for things to work. But the idea is, I was saying, what you can do is you can do something like this. Is it? You import PLT like that, and then you say, I want to draw. It's 50,50 or something like that, right? So that I draw a graph like this, right? It's simple kind of like pie chart or something like that, right? And so we'll see how we use Matplotlib, the visualization package, I guess. And then we'll also look at Seaborn. Now, the thing about visualizations in Python is, I think I mentioned this in the class we had last week, really, that what's perhaps interesting here when it comes to visualization packages really is what you can do with Matplotlib, what you can do with Seaborn, you can do with Matplotlib, but it's just that the things that you generate using Seaborn are much more visually appealing. And I think for those of us that were in attendance last time, I did this, is it? I showcased something. I said, if you go to Matplotlib, the website, right? It's so important that it has its own domain, matplotlib.org. And then you also go to Seaborn, Seaborn, the Seaborn website, right? Seaborn.pydata.org, just as a subdomain here. And you look at the galleries, right? So if you click on gallery for Seaborn, right? And you also go to gallery for matplotlib or examples for matplotlib, you begin to notice that the graphs associated with Seaborn are much more visually appealing, right? I don't know if you can see this. Look at the colors are wonderful. I wonder what we can use. A pie chart maybe would be a scatter. I don't see joint. I'm looking for box input. So there's a bit more diversity here, right? This is cut plot. I'm looking for an example that we can. What is this? Violin plot. I'm looking for examples that we can easily compare, right? One-on-one or something. Violin. I wanted to see if we could look at violin plot or something. So if you look at something like this, right? Compare and contrast with these, right? This looks like it's much more visually appealing, right? If you look at just the aesthetics, yeah? Compare it with this. I don't know what you think. But I guess, you know, who cares, right? Whether you've created this, maybe they do care. Whether you created this using Seaborn, maybe you get a promotion or something like that if you create it with Seaborn, right? So this guy knows what he's doing. I have no idea, colleagues. Okay, so we'll learn, the key thing here is we're going to be learning how to use matplotlib, and then we'll be learning how to use or how to create visualizations, plots, graphs, charts, right? Using matplotlib and then using Seaborn as well. And then apparently in module number 6, we're supposed to look at data wrangling, so techniques, right, for preprocessing, you know, how we normalize data, how we scale data with varying scales, you know, how we encode specific types of variables. And there's a particular focus on this, categorical attributes, right? So when you're handling data that has things like gender, male, female, if it's supposed to encode, that's categorical attributes, is it? Specifically, those are dichotomous attributes, right? But we know that there are different types of categorical attributes, right? You know, and all those things. So we're going to do that, how we handle outliers and anomalies in data. We're supposed to discuss this. It's quite a bit of fun here we're going to have, I think. You know, I don't know what's happening here with my thing today. I'm going to have to switch to my other connection soon because this thing is telling me I'm hotspotting here. It's telling me that this thing is going to switch off the APN or something. And then we're supposed to do a general introduction to machine learning techniques. So we're going to focus on specific, apparently we're supposed to focus on specific
You have gone mute.
and then afterwards, apparently in this particular module, you're supposed to focus on SQL. We're supposed to focus on SQL, right? No, what's happening with my phone here? It's so hot, I guess, because I've been teaching since I don't know what time. Okay, so ideally, hopefully this gives you an idea of how, here's the thing here. It's like, how do we get to a stage where we are able to work towards these learning outcomes? These are the learning outcomes. These are mapped onto these modules, the things we're going to be doing. Okay, if that makes sense. Anyways, so that's that. I don't know if there are any thoughts or questions about this. Any questions that we may have before we move on?
Is that all under one? I don't know if it's a topic or that's the whole course.
No. So this will be the whole course, actually. So this issue of topics is quite interesting, right? I'll give you an example. If I go to what we're supposed to start with, which is Introduction to Python for Data Science, I want to argue that our discussion of the technologies and the tools we're supposed to use can be seen as one topic. Your basic introduction to Python, the syntax and variables, data types, loops, and conditions, a separate topic. In fact, your introduction to Python can be made up of so many different topics, like the syntax, right? Variables, data types, loops, you know, conditional statements and stuff. So these are multiple topics, but what I've done is I've taken the approach where I'm going to be organizing these things we'll be discussing into modules. I'm calling them modules, but it doesn't matter really. I guess the thing that a lot of students don't like is when I'm organizing things as modules, your slides will be like in the hundreds, maybe 200 slides, right, for a single slide deck. But that's fine also. Hope that answers your question. Any other thoughts or questions about this? Okay. On that note, I mean, I've scrapped off part number 3, not necessary. We're going to pick up these things as we go along. So I wanted us to do how to read a paper, but I'd much rather we have a separate session to do this.
Hi, Rebels.
So we're going to do this some other time. But also, I think yes.
Yeah. So, are you going to share?
Hello?
Hello. Okay. Yeah. Can you hear me?
Yes, we can hear you.
Yeah. So, are you going to share for those of us that have just started the course, like this? Today is my first day. Are you going to share what you basically material that you used for the previous sessions?
Yeah. So it's literally the same slide deck, and I record these classes. I don't know if I recorded the last class. So I'm literally recording. I don't know. I'm recording this class right now. So what I can do is it working? I don't know if it's working. Let's see. I don't know if it's working here. I only have the class between 17. So it's working. I hope the last session we had worked. If it did, which was last week on Monday, which was so I can share what we did on the 16th. I hope, which is here, I guess. I don't know if it's recorded. So it's a short course, about 2 hours.
Oh, okay. That would be great.
Yeah, so I'll dump these somewhere and then I'll send details. Although we just look at Administrivia, right? The administrative part of the course, really. But there are a couple of things that we discussed. I've noticed questions pop up associated with the things that we discussed, last week. So if you're just joining us, when I will share the videos. When I share the videos, please find time and figure out a way of just quickly going through the 2 hours or something. Some parts are not that useful. Some parts may be useful when we're talking about how we're going to be grading the course and stuff. And in fact, my outline of we took a bit of time to try and answer questions that people had, course combinations and all those things. So please find time and do that. So I will share these things.
What about notes and study material? Do we write notes in the class, or we wait for the slides, or we just go through the recorded lectures?
I always share the slides, and at the end of my slide decks, I will have a bibliography which will link you to notes that I use to prepare the slides. So the slides offer a summary, but because when we have a class like this, right, I'll rant and talk about things that may not really be in the slides. So use a combination of those different things. So in terms of study materials, I'll be providing them as where necessary. I'll actually be also providing explicit materials, but usually it's references, right? Go and read this. If there's an interesting video, go and watch this video or something like that. Yeah.
Okay. Just a quick question on SQL. I didn't quite hear how much SQL are we going to be using?
Well, so not a lot. So if you understand SQL, if you have a little bit of experience with this SQL, structured query language, you understand this notion that SQL fundamentally is made up of 2 main parts, is it? You have your so-called DML statements and EDL statements, right? So your DML statements will implement what they'll call these CRUD operations, apparently, right? So CRUD operations, CRUD without the E here. You are creating, right? You are reading, you're updating, and you're deleting, right? Delete. And so you can map these really into SQL statements, right? Your create is insert, right? You're inserting records, right? Your read is your select statement. Your update is like your literal update statement, and map onto that when you're deleting, so delete statement or something. And then your DDL statements, you're working with your structures, is it? Your create statements and all those things, right? You're creating indices, you're creating tables and stuff. We are not going to look at DDL statements. we are exclusively meant to look at SQL from the perspective of querying, right? So in essence, the SQL we're going to study is, we are assuming data has been created for us. We don't care how, we are just going to focus here, ideally. So in terms of how much, we're studying the select statement, ideally.
Okay, thank you.
Okay, so quite a bit actually, because I mean, if you've played with SQL, you notice that there's actually quite a bit to know here, especially if you haven't really done any SQL. If you look at the select statement alone, right? How you do those projections, how you select data, how you filter, the where clause, how you order records, how you group, right? The group by clause, how you include like conditional statements in your group data, having, and all those things, how you join tables, right? Because in a real world setting, you won't have data in like a single table, right? It's in multiple tables, right? Which is why you have like the relations. So if you select this from this, right? Where this is equal to this, or select this from table 1, join, or left join table 2 or something, or right join, or full outer join, and all those things, right? So it's just a select statement, which should be, I guess, revision for some of you, but it would be quite fun for a good number of you. The thing about SQL is that, or SQL, structured query language, is that in as much as we've evolved beyond your relational database management systems, so gone are the days when we now exclusively store data as relations, right? If you look at these large-scale applications like Facebook, right? So if you look at Facebook, if you log into Facebook, it's like, well, I have my friends, I have my stream and stuff. There are groups that I'm a part of. That stuff is not stored in a relational database, right? That's suboptimal way of storing data. So they'll use like your NoSQL databases or something. But it turns out that the vast majority of data that you find yourself working with in a real-world setting is more likely going to be in a relational database management system. This is the case for most of these corporate entities like banks, telcos, right? They'll still store data in relational database management systems. And you hear them say, well, we have an application that has Oracle in the backend, or Microsoft SQL Server, or MySQL, or something like that. In fact, if we were to look at examples of applications that we use at the UNZA, and start some things that are closer to home, almost all of them actually store data. If not all of them, they store data, except maybe for modern applications, in a relational database management system. Academic promotions too. In fact, I'll start with Moodle, right? Literally behind Moodle is MySQL, which is SQL. It's a SQL-based database. What else? DSpace. I was using DSpace as an example. Well, you have Postgres SQL here. You run SQL command there as well, right? Typically, you can use Oracle, PostgreSQL behind the scenes, or MySQL if you want to, right? When you're setting up DSpace. The Open Journal Systems platform, right? This thing, when you're the journals.unza.zm platform, when you're installing this thing here, behind the scenes, this thing is powered by MySQL. The UNZA website, right? This thing here, it's powered by a CMS called Drupal, right? If you look up, this is Drupal based here. If you look up the Drupal CMS, if you just say Drupal CMS database or something like that, you notice that this thing uses MySQL, right? So when you're setting this up, you've got to first of all install MySQL, right? Before you can actually install Drupal or something. I don't know why they're not MySQL or higher. Well, you can use alternative, right? If you notice, apparently now supports several popular database management systems. So MySQL, MySQL, MariaDB. I have no idea what this is. Percona. It's the first time I'm hearing about SQLite. Incidentally, I mentioned last week that if you remember, I mentioned that in this course, I don't know if you remember this, but I said that the case example database is going to, I'm going to double back to the part where we're talking about this, right? I said we're going to use SQLite. It's lightweight, it's a lot easier to work with, it's quite simple, it's not complex, right? You can literally install it right now if you want to, right? And the application we're going to be using is DB Browser ideally. Hope this is making sense here. I don't know if there are any other thoughts or questions about what we're going to be doing. Okay. If not, then we can transition to lecture series number 2, and I'll call this mode. This can be module 0. I'll change this instead of L01. I'll call this M01 here. So we will transition immediately to module number 2, right? Which is it's tagged as Introduction to Python for Data Science. And I'm just going to ask for a minute. I need to grab a bottle of water, please. Thank you. I'll join you in a minute or two. All right. When we are now getting into the thick of things here, if you have ideas on how we can break during these 3-hour-long marathons here, I'm happy to receive suggestions from you. You know, sometimes I guess you get to a stage where beyond maybe 2 hours and things are just not sinking in, but you're online right there, right? So I don't know. I mean, in some instances, we'll probably be breaking off and then we have you do a bit of practice. Maybe we can try this today as well. But yeah, anyways, so lecture series number 2 is Introduction to Python for Data Science. And see, I've broken it up into 2 parts, okay? It may evolve into 3 parts, I don't know. But what you begin to notice is I've decided to just merge theme 1 and theme 2, okay? So if you look at what we have here as theme, and I have no idea where theme 2 is here, maybe here or here. I have no idea where it is here. But if you look at what we have in in theme number, which is here actually, in theme number 1 and 2, you notice that we have this, is it? We have Introduction to Python for Data Science, and then theme 1. Theme 2 is Python data structures. And so my thinking was, because these are kind of like linked, just merge them into one slide deck, one module. I'm happy to split them up. They're connected, right? It's all about Python anyway, but that's neither here nor there. And so what we're going to do in part number 1 is, I think it's just going to be a very gentle introduction to really what programming is all about, and then we'll kind of make a distinction between the 2 main types of programming languages, the compiled and interpreted languages. It's always nice to outline to provide a motivation for why you're using Python, right? In this particular course, why is there an obsession with Python when it comes to data science, right? The simplest answer to why Python in this course is, well, it's in the program document, right? The program document says we must use Python. And so Lighton has got to use Python whether he likes it or not. But we'll then also make sure that by the time we're done today, we must all set up our environment. And then we'll jump into the basics. Now, I want to say something here, right? This course is hands-on. If you want to get to a stage where you understand, you don't get lost by the time we get into next week, or we have a class over the weekend, you really want to make sure that you actually replicate what I'm doing here. So I will showcase how you set up your environment, and I'll showcase my environment and stuff. my expectation is that you're going to set up the environment on your machine as well. When we start looking at the basics of the Python syntax, for instance, I'll be showcasing very simple examples. My expectation is that you're obviously going to be trying them out, right? I don't think this is one of those courses where you can understand things by just listening to me teach or lecture, right? But you really want to try them out. You test them out. And when I share the code, you play them back. I'll typically be sharing these in a Jupyter notebook, actually on Google Colab, really, making it relatively easier for you to, to experiment with the code, change things and stuff. This is the only way, at least from my experience. I've been doing this since 2004, programming, right? So from my experience, you learn better when you do this, right? Yeah, 2000. Wow, so about 22 years. But yeah, so my first computer program was using the Java programming language, right? In 2004, literally, But anyways, so the question to ask really is, it's like, what exactly is a programming language, right? Well, so I made sure here I looked for formal definitions here. And apparently, a programming language is a formal language, right, that enables you to give instructions to a computer. And this is kind of interesting here, right? It's formal, right? Meaning that it has some sort of structure. And it turns out that is actually the case, right? Each programming language is typically associated with things like the syntax, rules, right? So if I'm using Python, for instance, right, I can't just say, I'm going to create a variable called, I'm going to create a variable called 1_Lighton, right? Period. Or one, it says first student, 1 is equal to Lighton period or something like that. It will fail. Why? Because according to the rules of Python, Python has rules. You cannot create a variable, right, starting with a number. It's not allowed, right? I guess you can start with an underbar, I think. I don't know. You can start with an underbar or an alpha, right? A character from the alphabet like S or T or something like that. So these are rules. And what else? If you have values, we're trying to assign variables to values, for instance, and I say number one is equal to 2026, so I have to figure out when we're going to graduate. And I say, well, print what happens, what value do I get when I add 2 years, because we're graduating after 2 years. I've created a variable number 1, and I'm assigning it a value 26. I cannot do the opposite and say, I want to assign 26 to the variable number 1. This will fail, right? Because it's not part of the rules. So it turns out that a programming language is a formal language, right? There are rules. And typically, the syntax is well documented, right? So if you just Google up Python documentation, for instance, you have access to detailed Python documentation. And true to that, this is the Python documentation. True to that, the way that you use this documentation is you do not memorize the documentation, is it? It's used as a reference. Of course, the basics you must learn, right? The very basics. But these are things you look up as you go along, ideally. So is this documentation, detailed documentation. You just go to docs.python.org, for instance, you have access to the documentation on how to use standard libraries and all those things, right? So the other part about this definition here is a programming language. Ideally, it's a language that enables you to give instructions to a computer. And this is interesting here because a computer is a piece of hardware, is it? Right? It's a piece of hardware, but the output, so we provide it with input, right? Using hardware components, like right now, I'm using my integrated microphone so that you are able to hear what I'm saying, right? And we have the hardware here that converts my analog signal, my voice, into digital form. It's passed through to the internet as ones and zeros and stuff. It comes to your end. It's it comes out of your speakers, right, as an analog signal, and then you're able to listen to what's happening here. A key thing here is it turns out that there's software, a set of instructions that are designed to facilitate that, right? So there's software that actually facilitates the conversion of analog signal into digital form, for instance, and transmitting it, right? There's software that is used to provide you with a visual representation of what I'm projecting on my screen, ideally. And all the while, right, if you think about everything that is happening here, the software we use, WhatsApp and Telegram and all those things, it's just a set of instructions, right? For WhatsApp, for instance, it enables you to transmit signals, messages, ideally. Right? So fundamentally, really, this formal language called a programming language is what we use to give instructions to a computer. Now, these instructions have got to be written and structured in a certain way, right? So we write computer programs, right, to perform a series of tasks. I can write a computer program that's going to enable me to calculate, right, things. So I'll build something I'll call a calculator or something like this. And then using this calculator application, users can use this graphical user interface to add numbers. Right? I can create software that is going to enable me to record screencasts, right, of what I'm projecting on the screen, like OBS, for instance. Right now, I'm recording. Right? So anyway, or we can write software that will enable us to analyze complex data. And so the key thing here is our interest in the course itself is to understand, in 6741, to understand how we write computer programs that are going to ultimately enable us to analyze data. Now, you begin to notice here, or you may not notice, but when you're analyzing data, there's a series of things that are happening, right? You have got to collect the data, right? And I'll use the CRISP-DM here. I like using this, the CRISP-DM. I'll talk about the CRISP-DM at some point, I guess. So it's in phases, right? In data. It turns out that you do this in phases, right? You've got to, first of all, look at, well, you have to understand the data, right? This has nothing to do with programming here. So let's say you're analyzing financial data. Somebody approaches me and says, well, I want you to create some nice visualizations about fraud, right? For a bank A or something. Well, the first thing I have to do is understand what goes on in the bank or something like that, right? Afterwards, I'll need to have an idea of what data, need to have an idea of the data I'm going to be working with, right? Right? And then afterwards, when I have an idea of the data I'm working with, I'll be creating scripts in here. I'll have to write a computer program, by the way, in computing, right? You know how right now, we are enrolled in a master of computing, in data science. This is a program like this, right? But because programming, I mean, it's heavily tied to the Americans and stuff. In programming, it's a program like this, right? This. I don't know if this makes sense. So the program in this particular case is going to enable us to collect data, right? A program, we can write a computer program to perform exploratory data analysis, right? IDEs, where we're trying to identify outliers and all those things, right? And then we come to data preparation or something like that. In here, we can write computer programs, right, to preprocess data. Like we write a computer program to deduplicate. We write a computer program and stuff, right? So quite a number, and so forth and so forth. There are a number of other stages here, right, where you're modeling, right? You're modeling. By the way, here again, you're probably going to write a computer program to transform the data, and you understand all these things when you get there, really, to derive fields and all that, right? Derivation and stuff. And then you write a computer program to create these models, right? The inference models. So when you preprocess, when you clean up the data and you preprocess it, one of the things you're going to have to do here is build inference models, right? Like it's something that's going to enable you to predict something and stuff, or something that's going to enable you to do a cluster analysis of data stuff, right? And then you have like evaluation, is it, to try and assess the relative success of the models and stuff, or whatever program you've created. Again, you write a computer program. Here you write a computer program, which would be like an inference mode or something like that. In here, you're writing a computer program to evaluate the success, right? And then you have like maybe deployment or something like that, right? Where you'll be writing computer program in this particular case to build a nice application, right? User application that users will be able to use, right? If you're looking at building something that is full-fledged. So the key thing here is that relative to what we're doing, we see that we'll be writing computer programs at various levels associated with our data analysis pipeline, if we equate that. Okay. Now, it turns out that there's a reason why we cannot use like natural language, right, for us to create a computer program, like something like I saw a man on a hill with a telescope or something, right? We have got to define things in a certain way, primarily because a computer, right, and this is interesting case to talk about, a computer expects these instructions to be formatted in a certain way. Now they'll tell you something like a computer understands ones and zeros. I don't know if you've heard about this, right? And literally the reason they'll say that is not exactly true that it understands ones and zeros, right? A computer understands electric signals, right? So in essence, what is happening in your computer is transistors are just like power is just being passed through transistors, right? Billions of transistors in a typical computer, right? In fact, I just say to give you an idea here, right? I'm just going to look up something here. We're not really looking at understanding computer architecture and computer systems here, but I'll just say approximate number of transistors in 1 plus 9R, which is my phone, really. Right? I have a 1 plus 9R. You notice here that it's about 10.3 billion transistors, right? So in your, this is quite small, but in your phone are these things that are just firing electric signals, right? And so the thing that we say, a computer understands ones and zeros. It's like what is happening behind the scenes is in all these different 10.3 billion transistors, depending on what sort of instruction is being executed, it's either you have a high voltage or low voltage. So typically a high voltage is associated with a 1, or could be seen as, you can abstract this as a 1. Low voltage can be abstracted as a 0, right? So this is why we're saying ones and zeros. And so you're writing these instructions in such a way that when they're passing through these transistors, they're going to make it possible for some transistors to be ones or zeros or something. And it turns out because you have a lot of these, and because this is done at a very fast rate, right? You're provided with an illusion like, oh, there's text on the screen. There's no such thing, right? This is just electric signal. There's no such thing. In fact, one of the things you may want to do here is to say at what rate, right? I'm going to come here. I'll just say processor speed for 1 plus 9R or something. I don't know if this is making sense here, but you will notice that the rate at which your processor works is so fast that you can't really even conceive some of these things. So the only way you can understand it is if you look at them at a high level of abstraction, if you will, right? So quite fast like that. Anyways, so computers understand ones and zeros. And because they understand ones and zeros, we have got to write these computer programs in such a way that they can easily be converted to ones and zeros. It's almost like if it were possible, which it is possible, we could actually write these computer programs as ones and zeros, and that is called machine code, by the way. But because machine code is error prone and it's notoriously difficult to learn, what we do is we abstract what the computer understands, right? So we abstract it in such a way that instead of working with machine code, right? We'll be working with a, what's typically called a, I don't know about here, a high level programming language. Now, Python is a high level programming language. In between here, you have things like assembler, for instance, right? Which is as close as you can get here. There's still assembler or assembly language code here. It's still used. If you're looking at writing highly efficient code, you're better off writing these computer programs at a low level of abstraction, where you're handling things like memory management and storage and all those things. But anyways, so a high level programming language, right? So there's a reason why we have got to use a computer. I mean, this programming language, right? Because we're trying to strike a balance. It's like it's two people speaking to each other. We're speaking to a machine as human beings. So what we must do here is strike a balance between using the language of the machine and using a human language, right? Notation. So what we do is we've come up with a syntax that has very weird things here, like print 2026 plus 9, right? So there are some things that you can easily understand as a human being, but they're written in such a way that it's a lot easier to translate them into a language that you can understand, ideally. Anyways, enough of that, right? Now, it turns out, right? It turns out that there are a lot of programming languages, and usually in life, right? When something is an integral part of society, you have a lot of variations, right, of solutions associated with whatever problem you're solving. So we have a lot of programming. I don't know if people here can take an educated guess as to how many programming languages we have here, but what I did today when I was preparing these slides, right, is I used Gemini, right? And I just issued a prompt here. The prompt was like random question: how many programming languages are there currently? And according to Gemini, here as of 2026, is about close to about anywhere between 8,000 like 9,000 plus programming languages. So this is like the way in which you can speak to a computer. Right? It's probably more than I don't know how many languages we have, human languages, right? How many languages do we have as human beings? I don't know. How many? I don't know. How many human languages are there? Right? Well, probably there are more computer programming languages than there are human languages. I don't know. Yes, slightly more, right? Apparently, about 7,107 somewhere there. But anyways, so there are quite a number of them, and the reason is simple. By the way, there should be like if you go to Wikipedia and they're curated lists for most of these things. You just say programming languages, or list of programming languages, and say wiki or something. You'll probably be redirected to a wiki page that has a whole host of programming languages here, right? So if we go here, list of programming languages, where I went to actually, these are ordered in alphabetical order, right? All of these are programming languages. Right? Now, I only know here, the first language I learned was the Java programming language, right? I've programmed in JavaScript, Python, certainly. You know, I dabbled in Perl because my master's and doctoral supervisor was the same person. He was co-supervising my work for my doctoral studies, was obsessed with Perl. I can do a bit of Bash. I don't know if Bash is here, programming. I can do a bit of Bash, you know, but it turns out that there's a reason I do a bit of awk scripting as well. I can do awk. I've done quite a bit of MIPS assembler, right? I don't know why there's maybe just assembly. It's classed as one here, but I've written MIPS assembler code because I taught a computer architecture course for a very long time. You know, so I can do some low-level code. I've not programmed in machine code, but you know, neither here nor there. But it turns out that there are a whole host of programming languages, a lot of them, right? Yeah, a lot of them. And really, the question you should be asking yourself is: if there are a lot of programming languages, why is it that Python is normally recommended as a language to be associated with data science in this particular case. There's a reason why. The other languages, by the way, like R, for instance, right? Typically, the thing to do, right? Just like we do in Zambia here, is like, what vehicle must I buy if you're looking at buying a vehicle? Or where should I stay? Just go, where do most people stay? It's like, what vehicle do most people drive? Toyota Corolla, right? I will buy a Toyota Corolla. Well, in programming languages, if you go with the crowd, you're okay, because you will find support online, right? So if you just do something like popular data science programming languages, you'll find things like R and Python. In fact, there are usually polls that are conducted. I don't know why my internet here is misbehaving here, but there are polls that are normally conducted. Like Stack Overflow does a developer survey almost every year or something, and they'll rank most of these languages, right? So you have things pop up here. Certain languages pop up, right? Like Python is typically top on the list with specific libraries here. With R, SQL, Java, Scala, and all those things here. But anyways, so there are a lot of programming languages, and maybe the thing for you to appreciate is, well, if there are a lot of programming languages, what's so special about them? What's the fundamental difference, right? In R maybe and Python, between Python and Java, and between C++ and maybe Python and stuff. Well, it turns out that we can view these programming languages from two main categories. There are two main classes here. Again, what I have here is just a reminder to say, computer software, these computer programs we're talking about, are typically associated with instructions. Those instructions can be represented using different languages, right? Low-level languages and high-level languages, right? So typically, high-level languages are used primarily by human beings. The low-level languages are typically associated to the machine itself. If you want to quickly or efficiently speak to the machine or interact with the machine, you use a low-level language. So for instance, your typical operating system would be created using a low-level programming language, right? Or a high-level language, again. So it turns out that when you write these computer instructions, for the computer to understand, what it means when you say print 2026 plus 9 in this particular case, because you understand this, the computer doesn't understand this. You need something to translate. Remember I said the computer understands ones and zeros, or machine code, right? Machine code. Now, if you are writing a computer program at this level, the question to ask is, how does a computer understand what is written at a very, very high level? Well, you need something in between. It's called a translator. It's a specific type of a translator. It's called a language translator. And interestingly enough, it's like a chicken and egg problem here, a snake eating its own tail. A language translator is actually a computer program that facilitates the conversion of one programming language notation into a functional equivalent code in a different language. So in other words, you can have a language translator that will convert something written in Python to machine code, ones and zeros that a computer will understand. Okay? So in the case of Python, in our case, we will need a language translator that will enable us to convert what we'll be writing, these things that are in a human-like notation, human readable notation, human language notation, into ones and zeros. Okay? Now, there are a lot of translators, right? Depending on what you're converting. So there are assemblers, right? There are disassemblers, right? There are interpreters, compilers, decompilers, right? So it's like if you're trying to convert a compiled language program or instructions written using a compiled high-level language into ones and zeros, you use a compiler, right? In fact, a compiler is what is typically used when somebody writes a computer program and they want to share it with you so that you install it on your computer, they'll share .exe file or something, right? Now, a compiler is what will create that .exe. Now, if you want to work in the reverse direction, you can use a decompiler, right, to derive what was compiled into code, ideally. It's like a reverse engineering or something like that. The key thing here is that you will need, sorry about that. I don't know why. I need to tell this person it's work related that the class here. Okay, so the key thing to learn here is that you need a language translator to do the conversion. Now I'm gonna say it here, right? That when we are using Python and we want the machine to understand the programs we're writing, we will use a language translator called an interpreter, because Python is an interpreted language, right? It's a specific type of high-level language. It's an interpreted language. Now, it turns out that there are two main types of high-level programming languages. There are compiled languages or compiled high-level languages, and there are also interpreted high-level languages. Okay, so in essence, the difference here is simple. You know, your compiler is going to enable you to translate your instructions, your computer program, into a machine executable program. So what you're generating really is something that can be directly executed on the program itself. And usually, it's a case that you will not be able to see the instructions that were used to create this program. You just see something that is, it's a binary file, actually. A .exe file is a binary file. Okay, whereas your interpreter is actually just going to translate the language statements, right, one at a time into equivalent machine code. And so typically what happens when you write a .py file, a Python file, a module file, you run a compiler. Every time you want to run that program, you're running a compiler on that file so that you translate the lines, instructions, one at a time. And now the thing here is that the fundamental difference is that if you're using an interpreted language, or if you're using an interpreter, or if you're using an interpreted language like Python, for a person to be able to execute a Python program, they must have an interpreter installed. So I wouldn't be able to run Python instructions without this interpreter. It has got to be there. If I share version, Python 3 version, if I share a .py file, so for instance, if I create a simple program here, I'm gonna have to, but how don't I have this? I'm gonna just create playground here and then go in playground and just create CSC 6741.py. It's a simple program that is just going to do what? To print 2026 +1 +2, right? So that we see also, I'm just going to say this, right? We are graduating in something like this. And then I'm just going to say Python 3 and then CS. So I've written a simple program here. So we are graduating in 2028, right? Now, if I share this .py file with you, you cannot execute it on your machine unless if you have this language translator that we are calling an interpreter. And you have a whole slew of interpreted languages, right? Most of these things like Perl, for instance, is an interpreter. So for me to run Perl programs here, I need to have Perl installed, which I do have, right? I need this interpreter, for instance, right? However, if I'm to run programs created using C++, I don't need any C++ compiler. I'll just tell the programmer, give me the program that you've created. In fact, the programmer will share the machine executable program derived after compiling the program. if that makes sense. Anyways, yeah, hope this is making sense here. The key thing here is that we're working with, and I mean, at your own time, I mean, you may want to look into most of these popular languages. Some of them are compiled, like PHP, for instance, quite common, quite popular. Our CICT at the UNZA, our equivalent of IT, most of the programs that they have here, like performance management system, this is a PHP, a PHP application created in PHP. What else? Moodle is created in PHP, although it's the CMS. Drupal website, PHP, right? So PHP, right, is an interpreted language, right? So what happens is when they're deploying this application here on the server where this Moodle is or where the performance management system is and stuff, it turns out that the PHP interpreter must be installed. And I think I probably have PHP installed here. I think the default PHP application, web application, I'll need this interpreter. So I'll install it ideally. I'm wondering why I don't have PHP. Wow, I don't have PHP. That's okay. Okay, so anyway, so some examples here: Perl, PHP, and of course Python, which we're going to be using. And there's some examples of compiled programming languages would be C and C++ and stuff. And they'll tell you that if you're writing code that is supposed to run efficiently, you better work with a compiled language, right? Because converting to machine code every time you're executing a program is not really that efficient. Hope this is making sense, right? Again, just showcasing an example of how you'd use a compiled language. In this particular case, I'm showcasing the fact that a programming language like Java is considered a compiled language to a certain extent because you need the Java compiler, right? So if I write a programming language, I don't know if I have Java installed here. I'll have to install it again. I would have to compile to bytecode the .java file. So I will create a .java file like this in a language, using the Java programming language. Syntax is obviously different from Python. It's more verbose and stuff. And then after I do this, the next stage is I have got to compile it using Java, right? So I'll just run Java on the file that has those instructions. And then I'll get back into the class file. This is what I will execute, ideally. Compare and contrast with Python, right? Where I just write it, I don't have to compile anything. But because I haven't compiled, every time I'm running the program, boom, I have got to use the compiler. Okay? Now the beauty is, most of these things they're abstracted away from you. Okay? So it's like when you are creating programs, you don't really have to worry about, what about the interpreter? The interpreter. What is important is you just remember that for the programs to execute, you need the Python interpreter. If that makes sense. Anyways, again here, just trying to, bring this point home here, the fact that software applications, implemented using compiled languages are deployed as executables. So if I write a program in C++, what I'll share with you if you had to execute my program is a .exe file that you can even install. Whereas when I create a program in Python, I share the actual code. I package it somehow, but you actually have access to the raw source code. And every time you're running a program, you need an interpreter to actually translate the languages on the fly. A nice thing about this is if you think about it from the perspective of a human being, right? The way we work with languages, it's like I want to interact with a Chinese person and I understand English. But how do I move from English to Chinese, right? Well, there are two options, right? Option one, I think, if I were to read option one, is whatever a Chinese person is going to speak, I'll tell them speak, 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 and then I'll use the translator to say convert everything they've spoken, right? Convert everything to Chinese. Everything I've spoken in English. Option two would be, I want you to be converting one step at a time, right? In real time or something. So as this Chinese, as I'm speaking in English, this person gets to translate or something like that. I don't know. That's the closest kind of example I could think about here. Then just to mention here that when you're again on language translators, if you're working with low-level programming languages like assembler, like MIPS assembler, for instance, you actually assemble a program, right? You're assembling the assembler code is assembled into machine code, right? So you're converting what you're seeing to the right here. This is literally MIPS assembler into equivalent ones and zeros. The interesting thing about assembler program is because you're closer to the machine code, literally each line can be converted into its own equivalent machine code, exactly the way it is. Right? So it's a one-to-one mapping ideally. Okay. In this particular case for MIPS assembler, you'll be converting it into equivalent to 2-bit instruction, right? So a stream of, it's like this instruction code, I'll give an example of load immediate into register 8, right? The value 0, for instance, and load immediate into register 9, the value 10. This, we can convert this into its equivalent stream of 32 ones and zeros, literally, right? Like in other words, in fact, I can just tell there's a way of doing this, but we're not learning computer architecture here. So I'm just going to call this and say convert MIPS assembler instruction into ones and zeros, into binary or something like that. So the equivalent, whereas when you're working with a high-level programming language, you're doing this stepwise, right? Because you're working at a very high level of abstraction. It's not that intuitive. But in the case of this thing is explaining, I just want ones and zeros. So the equivalent instruction that the machine will understand is this, ideally. Is this. And of course, I mean, we're abstracting things here. It's not, these are 32, by the way. 1, 2, 4, 5, 6, 7, 8 by 4 is like 32 or something. But it can see low voltage, high voltage, and all those things, right? Anyways, so you have that, right? And again, I'm just showcasing the fact that the program that you're seeing on the right, which is MIPS assembler, is associated, what the computer sees actually, it's a continuous stream, right? Because this, you see, when you have a computer program, although we're not discussing this, but maybe this will help you understand. When you are using an application like Chrome or Microsoft Word, what is happening is you are loading that thing in RAM, and as you are clicking, those instructions making up that program are actually sent to the central processing unit, the CPU, right? And they are sent as a stream of ones and zeros, so that your actions are translated into the output that you are seeing. And you will happily think that, oh, I typed T, and that's why I'm seeing T there, right? You know, so behind the scenes, like at a very, very fast rate, when you type F here, there are instructions that are sent to the CPU, you know, to say the end result here should be, when the instruction is processed, the end result is going to be, you fire the letter F at a particular, or you draw something that looks like an F at a particular location on the screen. I don't know if this is making sense here. Now that we understand the key thing here, right? Python is an interpreted language. So you need a language translator called an interpreter for you to be able to execute the code. I guess now would be a good time as any to maybe provide a motivation for why Python, right? Well, I talked about surveys that are done. What you're looking at here is, I think this is, I don't know if this is from Stack Overflow developer survey or something, I'm not really sure. This is quite old here, but this was done in 2019, right? And you have participants here, is it? Over 2,000 participants, and these participants were asked a series of questions. But what's interesting here is you notice something interesting interesting, right? The fact that Python happens to be one of those most widely used applications when it comes to DS, which is data science, ML, machine learning, and to a certain extent, we're working with the Internet of Things application, right? So applications that are going to run on these so-called Internet of Things centric devices, ideally, right? So it's most popular for, if you notice, popular for data science, machine learning, and Internet of Things. It's least popular when you're developing mobile applications and games. If you look at JavaScript, most popular for web applications, right? It's least popular for, so you get the point. So there we go, motivation, right? This happens to be the reason why a lot of people gravitate towards Python, if you will. Right? There are other, stated reasons here that I've included for simplicity and readability. I had such a hard time. If you're learning how to program for the first time, you notice that Python is very easy, extremely easy. I struggled with Java. I remember this like it was yesterday, right? 2004. It was horrible. It was. I started off with memorizing things because initially I couldn't even understand what was going on, right? But I realized that I could memorize like for me to create a class, right? I just need to write public class, name of the class, without even like really at that point really understanding what was going on, right? But with Python, you begin to notice that it's so easy that it's a lot easier for you to understand what is going on rather quickly here, right? Most of the things you're going to be using, they'll read like, it actually reads like English, right? Look at this. Even if you don't understand Python, and I tell you that, I'm telling you that, what do you think this does here? If I say print, welcome to CSC 67, 41, like, I expect this to print that text, and truly it does, It's crazy here. But with Java, for you to accomplish the same thing, right, is welcome to CSC, you would have to, it's crazy here, you'd have two variables here, public class, CSC 6741, right? Curly braces, public, static, void main, right? String, hugs, crazy stuff. String hugs, braces, system.out.println, right? And then I'll just say, welcome to CSC 6741. Yeah, it's like, it's hard here, right? I mean, for you to understand you can't, like, it's difficult to make out what is happening here. I mean, you can read this, it says welcome, but it's difficult to know what is happening here, right? What is print line, system.out, but in here, right? Like, I can intuitively tell if I print this, I expect this to print. Now, whether it's going to print to the console or somewhere else is inconsequential here. It could be somewhere else, but what I do know is that it's going to print something. So it's easy like that, right? It's interpreted and interactive, so I can interact with the interpreter, right? So when you install your interpreter, I'll discuss how you install the interpreter. You can interact with it in so many different ways, right? Like literally on the terminal, like I'm doing here, it's quicker for me. I can literally interact with it right now. Or you can use Google Colab. I showcased Google Colab, if you remember at the very beginning. I was, where was I? No clue. I was here, right? And literally, I'm interacting with the interpreter here, right? Here, I'll create something else. Here, I don't need to worry about anything. I'll just say print, welcome to CSC 6741. Boom, I see this, right? So I can interact with the interpreter. So quite useful like that. So it allows for what I guess you would call exploratory programming. So as you are interacting with your program, you can make minor modifications and then really see the results right there and then, which is very, very useful. Right? It also has a relatively large ecosystem, a ton of useful libraries. I just showed you something here. I'm teaching a what is this now? I'm just going to deactivate this. I'm teaching a source.pd activate or something. I'm teaching a computer graphics course, and the libraries that we are using, right? There's this Python is generic, it's general purpose. For us to use it for graphics programming, computer graphics programming, because it has a large ecosystem, all I do is I install these packages, and I'll be able to draw triangles and vertices and edges and all those things, right? Or rather, I'll be able to interact with the OpenGL API, right? In our case, we are using, I told you this, right? We are using, yep, so I'm in this environment here. We are using a series of libraries. If I list these things, right, I've been able to install all these libraries because they're going to be useful in what we're doing in 741. Now, so in essence, I've modified Python in such a way that it's going to be used for data science. If I wanted to create a web application, I would actually utilize libraries that are specific for that. If I wanted to create graphical user interface application, like I wanted to create a calculator like this, because this is GUI based like this, I would use maybe Tkint or something, right? I use this, is it Tkint or something? We did quite a bit of graphics, GUI-based programming with first years when I was a graduate student. So we were using Tkinter, right? Where you're creating these sort of applications here, graphic-based, right? Desktop-based applications. Anyways, but we see here that because Python has such a large ecosystem insofar as what we're doing is concerned, we shall use it, we shall extend it to try and see if we can do a bit of numeric computation for efficiency reasons. So we use NumPy, pandas for data manipulation and analysis, matplotlib and seaborn for visualization, graphs, and then scikit-learn for creating very simple inference models, right, for machine learning, ideally. But it gets even better. If you look at most of these AI-centric frameworks that have been created, I mean, if you've dove into this field of AI, you've probably come across names like Keras, right, TensorFlow or PyTorch. These are all Python-centric frameworks, very powerful machine learning / AI-centric Python libraries or frameworks, right? And it turns out another reason why we're using Python is it's relatively easier for you to integrate it with other languages and tools. And then, of course, there's massive support. Chances are, if you interact with somebody and they tell you they program for a living, they probably know how to program in Python. Anyways, I don't know if any questions. I thought we'll do a little bit of setup now. Any thoughts or questions? Okay. If there are no questions, we can proceed, I guess. Is there a question? Okay. No question. That's fine. Okay. So the first thing then is, I mean, you've, like I said, right? We're saying that Python is an interpreted language. So when you write your Python code, you need the interpreter, right? So the question is, I mean, how do we install the interpreter? Well, the easiest thing to do is you go to the Python website. There's a dedicated website. So if you just Google Python or you go to python.org, you shall come across this website. And on that website, you shall find links, right, to download this Python interpreter for your environment. And I'm saying for environment because in all likelihood, you guys are doing, I mean, are using all sorts of operating systems here, right? So, you know, it's like for you to download the interpreter, first of all, I've got to decide on which sort of platform you're running, right? So in this particular case, the way the browser works is it knows, it knows that my browser knows that I'm running Ubuntu, right? So it's telling me that click here to download. In your case, you choose Windows if you're a Windows operating system, Mac if you are running on Mac or something. Okay? The interpreter. So you want to make sure that you download the latest version, version 3. If you're looking for a specific version that I have, I'm running version 3.12.3 ideally. Okay, 3.12.3. Okay. Anyways, again, if you go there, you'll be able to find instructions about your setup. It's just like installing any piece of software, really. It's not that difficult. But I have a recommendation for you, right? In as much as you can get Python from here, my advice is, and we can turn this into homework, my advice is use the Anaconda distribution, right? So if you go to anaconda.com, and you go to download, you will be able to find instructions on how to install this distribution for your operating system, ideally. The beauty of doing this is that you not only have access to Python, but it will also include all of these popular packages to do with data science. Right, so NumPy will be included. At some point, I'll start walking us through how to take advantage of reproducibility when you're working in data science. So how do we use Jupyter notebooks and stuff? So Jupyter notebook will be installed for you, making it relatively easy, really, for you, right? Anyway, so again, if you want to install Anaconda, the Anaconda distribution, you just go to anaconda.com/download, and then you follow the instructions from there. Okay. It's really easy instructions, to be honest. The only thing you need to do once you install Python is or Anaconda really is you want to verify that the installation was successful, so you can check the version right in the terminal, Python version and Conda version ideally. But as a starting point, just downloading Python here and installing it should be fine, fairly fine. And then we'll install these libraries as we go on, ideally. Now, there's something interesting here, right? You noticed I was writing commands here. Well, I was writing commands here, right? These things here. I was also writing commands, well, I was showcasing commands associated with different languages. If I can go back here, these things here. A typical program, right, will be associated with, it's not just going to have 2 lines or something, right? It will have hundreds of lines, ideally, of instructions that you're writing. Now, when you have a number of instructions that you're writing, these instructions are associated with your computer program. In fact, I can showcase some example here. I'll look at some of these packages that we have, right? I'll go into the environment and then probably go into bin. I don't know if it's lib or something, side packages. Let's try NumPy, right? And try and open one of these files here. I don't know what matlib is. I don't know what these are. If you notice, you'll be writing things like this, right? And this file alone has 380 lines of code, right? These are like the instructions that you'll be writing, these things. It can be much, much longer than this. Now, the question to answer here is, well, what do we use to write these instructions? I mean, if you've been programming for a very long time, what you can do is you can say, well, I can just use a plain text editor, right? Like I was using, in this particular case, I'm using an editor called Vim, right? So if I do a man on VI here, I'm using an editor called VI Improve, the programmer's text editor or something, right? But it turns out that what you need is what you, I don't know what else, demonstration of, yeah. I don't know what I need to demonstrate here. I guess it's my environment or something, Python environment, but now I can demonstrate this afterwards. What you need is what's called an integrated development environment. Okay? So the idea behind an integrated development environment is it's a piece of software. It's like we're creating software using a piece of software. You know, how cool is that? Just like we create chickens from chickens, I guess. But your IDE or integrated development environment is a piece of software that will give you access to a tool set for you to effectively create your computer programs. Now, you'll notice something here. If I'm using a plain old text editor, for instance, there are certain things that I'm unable to do, right? Like code completion, right? So, but if I'm using a full-fledged editor like this is Visual Studio Code, or it's a text editor, not an IDE really. You know, I'll talk about IDEs just now. But the idea behind, I'm gonna open a new thing here, and I'll just call it CSC for 67 41.py. In here, I can say print look at this. If I wanted to create a function, I would say DEF. You notice what's happening here? I don't know if you can see. There's a bit of auto completion here, right? I'm just going to zoom in. I don't know if I can zoom in. Control plus. How do I zoom in? Ah, there we go. Look at this. As I'm typing here, right? I'll delete this. As I'm typing DE, right? DEE, this Visual Studio Code knows to say, if I type DE, either I want to type DEF, which is a definition function definition, or maybe DEL or something like that, right? So there's a bit of autocomplete. Not only is there autocomplete, but observe, if I say, okay, if, okay, I'll just say var grade is equal to 50 or 55. And then I'll say if var grade is greater than 55, no, is greater than 50, then print. You notice here, when I'm typing things like print, right? There's a bit of auto completion. This is one of the strengths of an IDE is it helps, it prevents you from making mistakes. So it'll be things like autocomplete. You can easily debug problems. I'll print here, pass. And then I'll say else print fail, something like that. Fail. If you notice, if I just type fail here, you notice how there's a wiggled line here, right? Fail. It's kind of like underlined using a wiggled line, telling me that there's a problem, because if I run this, it won't work, right? If I run this, it won't work. I don't know why it's fail. It's if I pass maybe to fail, maybe if I say 41 or something like that, it should fail here. Why isn't this? I don't know why this thing is not working. It should fail. And I have no idea why this thing is it's horrible here. It's just not, this shouldn't work here, right? Because fail doesn't exist, is it? Or what I'll do here is I'll just remove this passing quotes here, right? And run this. Oh, I didn't save it. I'll save this and then I'll run this. You notice this text here? It's telling me that, look at this. It's telling me that, you may not see this here, but I'm just going to copy this content so that I paste it where you can see it nicely. I guess I'll paste it here. It's telling me that there's an error, right? right? There's an error here. This thing did not execute successfully, saying name error, name pass is not defined. Now, this is possible because of the fact that there are tools available within the Visual Studio Code, right? This thing is being underlined. It's pointing me exactly where there are problems that I need to fix or something. That's the power of an IDE. So in addition to your interpreter, before you actually start, you can start writing these computer programs. You have got to install an integrated development environment. Now, similar to programming languages, there are a lot of Python IDEs to choose from. I'm showing you an example of Visual Studio Code. It's PyCharm. For the longest of time, there's I'm trying to remember here. I'm losing my memory now. But we used a tool called it has a one Wing. We used to use Wing. I was teaching first years, Wing 101. I do recommend this. It's Wing IDE, quite easy to use. But if you want, you can experiment with Visual Studio Code as well. I don't know. Just as well. So is that, but what you'll notice is that in this course, most of the examples I'll be showcasing, I'll be using, you can call that an IDE really, but it's an environment called Jupyter Notebooks, right? And the idea behind Jupyter Notebooks, as the name suggests, if you're in the sciences, is similar to what you used to do when you had the lab logbook, where you document details about your experiment. You're doing the same, but using a piece of software. So again, the Jupyter Notebook is like an encapsulation, right, of like instructions and visualization, extra content and all those things. Okay. Anyways, so that's that. So I'll talk more about Jupyter Notebooks here and Google Colab and all that here, but really a Jupyter Notebook is nothing more than it's a web-based application really, which provides you with an interactive environment. This is the environment I'm talking about. So you can literally just write your programs in here. Okay. Anyways, and the reason we're doing this is it's really perfect for data exploration and storytelling. So these stages of your typical pipeline, I don't know if you remember this, when I was walking you through this, you can literally include them as a sequence in your notebook. And then you just share this notebook with your boss or a colleague or something. And then they'll be able to get the same results that you get. Okay, so is that. Now, if you're interested in exploring, remember I said there are a lot of IDEs in computing. Whenever there are a number of options, you usually have wars, is it? No, Vim is better. Visual Studio Code is better. Wing 101 is better or something. I'm going to leave it up to you to experiment, do your own research, and figure out what sort of environment you'd want to use. I'm merely offering recommendations based on my experience in the past. Some of these things I haven't used in the recent past. Like I've not used Wing in a very long time. I used it extensively when I used to teach Python when I was a doctoral student. So that's between 2014 all the way up to 2017, or 2013 all the way up to 2017, right? But if you go to this link here, you'll find people, right? So if you go here, you'll find that these conversations, just like we've been having conversations about what happens when we die or something. There are conversations that have been going on, like which IDE is better when you're using Python, right? So there's this nice thread from Stack Overflow. It has 1,022 votes. It's from 17 years ago, but still highly relevant. So you have a response like this, where they've provided even a spreadsheet version of the different sort of tools, right? IDEs that you can potentially choose from. And what these people have done, I don't know what that is here, but what these people have done, if you notice, is they are providing what? They're providing, I don't know why I can't zoom in here nicely. I don't know why I can't zoom in. They're providing aspects, right? Is it cross-platform? So can you run it on Linux, Windows, and stuff? Is it commercial or non-commercial? You know, does it offer code completion? Does it have multi-language support? Does it have Python debugger integrated? And then you can get to choose, right, what you want. But what you notice from this list is it's not. I was expecting a lot more here. Can I see Wing? They left out Wing 101. They have. Yeah, this is not a nice response. I don't know if there's another response here. There's another one here, which is perhaps much more comprehensive, I guess. A lot more options here, is it? Anyway, or this is 2026, ladies and gentlemen. What you can do is you can say, I want to go to ChatGPT or Gemini or DeepSeek and ask, list the most popular Python IDEs and order them in order of the best or something, whatever, and then we'll let this thing kind of like organize these things. Or you can tell it, you know, you can specify metrics or something. So Visual Studio Code is number one, right? I have it here. It's PyCharm, right? There's Jupyter Notebooks, which we're going to use. So you're going to see me use a little bit of Visual Studio Code, but certainly a lot of Jupyter Notebooks and Jupyter Labs because I need to share code with you. I've never used Spider before. You know, I have no idea what Thorny is all about here. You know, so quite a number of, and you can even choose, I want this list, I want this to be comprehensive. Add more options or something like that. And then you can get to choose yourself, right? So you want to really play around with this. Visual Studio Code, PyCharm, Cursor, okay? You know, look at this, tier 2. So this thing is organizing them in tiers, is it? Best overall, and then data science and research specialists, Google Colab and stuff. You know, these are lightweight editors. You know, education and beginner tools. Okay, I've used Lido before. Say not, I have no idea what Moo is here. Wing IDEs here. You know, so quite a number of options here. Anyways, so you need an IDE. Now, if you've been following through, right, the number of things that I said you need so far, is it? We said that for you to be able to write Python code, at the bare minimum, you must install the Python interpreter. You must install an IDE to write the instructions. So far. Okay? These are things we'll follow through as we go along, I guess. I'm just showcasing here. This is Visual Studio Code. Okay. You notice that what I have currently looks slightly different here because I mean, kind of like made modifications to how it should look like and all that because I use it for so many different things. I teach a number of courses here. Okay. And just to mention that you can extend Visual Studio Code. One of the reasons I like Visual Studio Code is you can install quote unquote add-ons, right? Or extensions or something. The extensions here. So there are Python-centric extensions that you can install so that you can even write Jupyter notebooks within your Visual Studio Code, if you will. All right, I want to pause here and ask if there are any questions. I don't know if people are still around here.
Yeah. Yes.
Yeah.
So,
yes, we're around. We're around.
So for Jupyter, you can also install it on Visual Studio Code.
Not quite. So, and I want to get back to Jupyter Notebooks. So Jupyter Notebooks is like a separate application, right? So here's the thing. You say the Jupyter can also install it where? Can you repeat your question?
As an extension from
Yes,
VS Code.
yes. No, so the idea is you have an extension that allows you to edit notebooks, Jupyter Notebooks ideally within Visual Studio Code, so that you don't shift focus. If you don't, then you need a separate application, which is Jupyter Lab or Jupyter Notebooks or something like that. But really, all of those things are not really going to be useful because, at the very least, right, for you to be able to write programs, the simplest thing for you to do is you go to research.google.colab.research.google. That's it. Right? So if you go to, where is that thing? If you go here, colab.research.google.com here, you will, like literally right now, you'll be able to start writing Python code. But you see, this, it acts as an IDE, right? But it's cloud-based. Now think about it from the perspective of what you do when you're using a word processor, is it? You can use Microsoft Word, or you can use Google Docs. The only disadvantage is if you're somewhere in Chinsali and you have internet connectivity issues here, it's like, it's a cloud-based service. Right? I was in Chinsali, I struggled like that, right? No classes for 1 week, right? So, which is why you would need as getting started here, maybe a local application, Jupyter Notebooks or Jupyter Lab, right? To be able to create your notebooks, and then you can sync these things with Google Colab, ideally. You know, but to get started, this is 2013. What I want to suggest is I want to do this here because this will probably spill into, if we continue with this, it will spill into things here because we need to have a discussion about how you create a notebook and all that. There's different components, and then we have a discussion of Google Colab. So what I'm going to do is I'm going to say, at the very least, what you must do between now and the next time we meet is install Python, the Python interpreter, install an IDE, and then for now, just go to colab.research.google.com, right? So that you can already, in fact, when you go to colab.research.google.com and share this direct into the income messages, when you got there, what you want to do is just try and see if you can create a notebook and just write print welcome to thing for now. Don't worry about what it means or something like that. When you go to Colab, you'll be presented with a screen like what you will see here. It will load, right? Like this, there'll be a pop-up window here. Click the button that says new notebook. Bottom left, it's blue here, new. When you do that, you can give it a name, whatever name you want. So you give it a name, same way you give names to Google Docs documents. So top left corner here, notice this is an Untitled Interactive Python Notebook, right? Untitled 22.ipynb Interactive Python Notebook. So you can just name this something like, you can just name this, I don't know, maybe CSC 6741 lecture 2 or something like that. And then in this cell that says start coding here, just type print in double quotes, welcome to CSC 6741. We're going to do another welcome later on here, but welcome to CSC 6741. And then you can click the play button here to run, and then you see an output here. Now, what I'm showcasing is you can use Google Colab as an IDE, right?
Yes.
And it will work. It's just that the only thing is you need to be connected to the internet for this to work. Is this making sense? I think it's enough for today. We shall meet, hopefully Saturday or Sunday, probably Saturday or something, and we shall then have a discussion about reproducibility, right? How we use Jupyter notebooks and Google Colab. Explain those cells that you're seeing and stuff. We'll look at Markdown and all those things. And then we'll discuss, how powerful Google Colab is, because you can link Google Drive. Powerful thing, this one. Very useful. I use it all the time myself. And then we'll immediately get started and start learning the language, the syntax. It's like we're going to be learning, it's like when you're learning a new language, right? You want to learn how to speak Chinese. Learn the syntax, right? This is what we're going to do here. I'm going to pause here and ask if there are any specific questions about today. I think people are tired or something like that, right? Sadly, it's going to be like this until April 17th. I can't see the screen, sorry about that. Evening Doc, you have gone direct into writing syntaxes. Not quite, I was just waffling around using examples. Others may not have Python on their computers. Yeah, we haven't yet started doing that. We'll only start doing that. I think this was at the very beginning, because I see it was 1836. We will only start doing that when we meet next in the next session. So we haven't even started discussing the syntax, but for me to showcase some things, I was just writing simple instructions like print, and adding numbers and all those things. All right. Okay, if there are no questions, thank you very much. I will see you when you see me. Can I ask that maybe the course rep reach out to me if we can maintain the same day we're supposed to have class? Remember, the other day, we're supposed to have class, this one, on, we're supposed to have class on, this is March. We're supposed to have class on Saturday at 17:30. For planning purposes, it usually helps me. If you can agree as a team, if you're okay with us doing this 17:30 next week, before Thursday or by Thursday, that will really help with my planning. But I think there's a hand up. I saw a hand, I think. Please. Oh, it's gone. Okay. Okay. Thanks a lot. By the way, as we're doing this, you notice that this is quite intensive, too technical. So in the exam, obviously, there will be questions to do with code and all that. So just keep that in mind as we are getting started. Okay. I know the exam is only coming in April or something. Yes, Mr. Mahango. So Aiden has a question.
Good evening, Doc.
Yes.
I was just requesting for your email address. I think I've not had an opportunity to see it anyway. I remember last time in the lecture you shared that we needed to be contacting you using your email address.
Yeah. So lightonbepira@unza.ac.zm is how you get through.
Thank you so much.
Yes. I've just pasted it there. All right. Good night, everyone. Then we shall see you on Saturday, hopefully. Bye.
Bye.
Bye.